All right, so the pole position P or Q. Again, two variables. So you have P and Q, 2 to the power 2 is 4. I have 4 possibilities. So for P, I have 4 I split into 2. So I have true, true, false, false. For Q, I split those into half again. So I have 1 true, 1 false, 1 true, 1 false. All right. And now for OR, you only need one statement to be true for the whole thing to be true. For example, true and true obviously is true. True or, so true or true is true. True or false is true. You see, you only need one of them to be true for the whole statement to be true. All right. False or true, again, is true because you see there's a true there. Now look at this. The only time you get a false is when the first statement there is false and the second statement is false. So you have both of them being false. Then once you apply your bijunction or your disjunction, you're going to get a false. All right. So the reason why I'm emphasizing this because I can actually give you a truth table and I give you what this looks like. So this one here is false, but I don't tell you what happens here. All right. You should be able to tell me that it's a false and a false there because that's the only way I can actually get a false if I'm talking of P or Q. All right. So you need to watch out. I see there's a question there. You see the 2 to the power just tells me how many combinations of lines I'm going to have. Okay, I'm not sure what you mean by lines. It tells you the number of combinations. It tells you how many possibilities, how many true and false do you have. All right. When I talk of possible combinations, for example, if I ask you to toss a very fair coin, you only have 2 possibilities, right? So if you toss a coin, you have 2 possibilities. You can either have head or tail. There's no other possibility. That's the reason why I started with the word a very fair coin. All right. So the fact that you have head or tail as your possible combinations, it means that in this case, when we talk of 2 to the power and give you that combination, again, it means that these are the possible outcomes, all right, that actually exist. So for example, if the first statement can be true and the second statement can be true. The first statement can be true and the second is false. The first can be false, the second is true, and the first can be true and the second is false. Those are all the possible combination that you actually have. However, you need to keep in mind, when I talk of possibilities, I'm looking at this whole thing being one possibility for both P and Q. This whole thing here be another possibility. So you see how many of those you have? You have 4 of those. All right. You have 4 possibilities for both P and Q. All right. So one statement can be true, the other is true. One is true, the other is false. One can be false, the other is true. Or both of them can be false. All right. So 4 possible combinations. But like I said, it's very important that you start in this order just to make my marking easy. Because if you mix them around, the outcome is going to be a disaster, right? You're just gonna you're going to lose marks for all of us being wrong. All right. If everyone is happy with all, let's discuss if then, all right, or the implication. We call it the implication. Guys, this one is I don't want to use the word the most important because in logic, everything is important. But this one is the one that there are many ways that we can test you on, all right? Because it has so many possibilities. Before I go to this side, which is so important, you need to know, I'm going to first of all explain what the truth, how we get the truth table. So 2 variables, again, 2 to the power 2 is 4. You see there I have 2 truths, I have 2 false in that order. Then I split this into half again. So I have true, false, true, false. All right. Please don't swap it around. Don't start here and say true, false, and then true, true, true. If the minute you start mixing them around, it becomes difficult for me to mark. And then I wish most of the time you end up just having the wrong output here. All right. Now, what do we observe here for implication? All right. For implication, you notice that when you have true implies true, your outcome is always true. All right. If you have true implying false, you see your outcome there's false. And this is the only time it's going to be false. When you have true implying false. So a true statement cannot imply a false statement. That's what implication says, all right? But however, a false statement can imply a true statement. So false implies true, is equals to true, all right? And a false statement implying a false statement is equals to true. It means that false implies false is actually true, all right? So we say that for implication, the only time you have is false is when we have a true followed by false, all right? So watch out. If I give you a true table and I say fill in this true table and you see a false here under implication, then you can already tell what happens there, all right? You know it has to be a true followed by a false, all right? Someone says I should upload slides. Okay, the slides have been uploaded. Like I said, if you go to the directory, the link that I sent, this note is already there. The whole logic note, I've also uploaded it, but I want you guys to use my handwritten note because it's summarized. If you go to the complete logic note, there will be a lot of theory there for you to read. If you have enough time in the world, go and read those, but preferably look at my handwritten note. All right, now very, very important is this. If I give you a statement P implies Q, now the first piece of the statement we call it the antecedent, and then we call this the consequent, all right? Well, the reason antecedent and consequent means this happens because of this, all right? So it's almost like the consequence of P. Q is a consequence of P, means that if P, then Q. Obviously, it means if P doesn't exist, Q will not also exist. All right. Now, there are many ways of writing implication. Guys, pay attention. You can read this sign, so this arrow there. You can read it as P implies Q. All right, so it's implication. You can say if P, then Q. So if you choose to use it as if, then it's fine. So it starts with P. All right. So I'll just put P, then I'll put Q here. So we say if P, if the first one, then the second one. So if P, then Q. Now, I can still say only if. So I can say P only if Q. Guys, you need to watch out, all right? Because if I give you a sentence and I say P only if Q, I'm still talking of the same thing, all right? It's still P implies Q, all right? So only if is the implication. Now, if you don't want to say only if, you want to say if, you have to swap the variables. All right, so Q if P. Now, this is why most of you actually get so confused because you choose to, instead of saying if then, some of you just say P if Q, which is wrong. You can't say P if Q. You have to swap the variables around. So it has to be Q if P. So if you say Q if P, I'm still talking of this same thing here. All right, it means P implies Q. All right, or I can say Q whenever P. Q whenever P, this means P implies Q. All right. Please know these 5 possibilities because definitely you're going to see it in the future somewhere. All right. Someone said, what's the difference here? They say true implies false is false, and false implies true is true. All right. There is a difference. The difference is now in the order. Truth followed by a false is a false, but false followed by a true is a true. All right. The same way I'm trying to emphasize that you should pay attention to this last 2 because this is where most of you get this implication wrong. All right. Order is very important. If you want to write it in the form, if you want to use only if, then make sure you swap them around. It has to be Q if P. All right, so there's no difference or there's no major difference, those statements that the guy was asking. But then order that's important. What comes first actually changes the outcome. All right, so truth followed by false will always be a false. All right, or in other words, you cannot have a true statement that implies a false statement. It's as easy as that. All right, but however, I can have a false statement that implies a true statement. All right, that's the beauty of logic. All right. Okay, so someone say I should check C row number 3. Okay, I'm not, okay, let's look at C row number 3 so that this student will be happy. All right. This is C. Row number 3. This is false implies true. Now, if you notice it, the reason why you have true there is because we're talking of a disjunction, not implication. All right. I hope it is not very clear. So there's a difference between P or Q. All right. So all means I just need one of the two statements to be true for my outcome to be true, or at least one of the statements to be true for my outcome to be true. All right. That's why here I have all two of them to be true. Automatically, my output is true. The second line, at least one is true, so it has to be true. At least one is true, it has to be true. None of them are true, that's why it's false. So for a disjunction, at least one of the statement needs to be true for it to be true. All right. However, for implication, guys, it's a different statement. All right. So this logical connective or is not the same as the logical connective imply. All right. Imply means something needs to imply another thing. All right. If P implies Q, it means that the only way that can be true is if they're both true. So if they're both true, it works. But if you have false, if you have false implying true is still true, it's fine, because a false statement can imply a true statement. However, a true statement cannot imply a false statement. All right. So the difference in C and D is they're logical connective. We're talking of or and implication. They're different. All right. Well, if you have any more questions, send me an email. Because like I said, this is the very basic. It's going to get super exciting as we go along. Super, super exciting. Now we go to biconditional statement. All right. Guys, this is so important. Please remember this. Although I've said it many times already, that you can replace if and only if with the implication on both sides. For example, you say P implies Q and Q implies P. All right. So let's see again the two variables P and Q. 2 to the power 2 is 4. We say true, true, false, false, true, false, true, false. And look at how it works. So true if and only if true is true. False if and only false is true, and everything else is just false. So for biconditional statement, you need to have the same truth values for both statements for you to have an outcome of true. All right. So know what the difference is with A, B, C, D, and E. Know when things are true and when things are false. So we're talking about biconditional statement. We need both statements to have the same truth value. All right. Either the same truth value of true or the same truth value of false. All right. For your outcome to be true. The minute you have one true, one false, or one false, one true, your outcome is just false. All right. So it makes it easy. If I give you a truth table and I say complete the truth table, you should be able to tell me what comes here, all right, or what comes here, all right. If everyone is happy, I'm going to move on. Is there any question regarding biconditional statement? Okay, someone said they want a second to explain what they're saying. Okay, someone say all clear. If you still have a question with any of this, please just email me. We just have 30 minutes left. And then we can have a whole session where you understand logic. If you want even advanced logic, we can discuss in terms of circuit designs. All right. Let's look at priority order among logical connective. There is order, there is priority to logical connective. Something takes priority over the other. All right. Let's see. The number one priority logical connective is negation. So negation takes precedence over everything else. All right. So there you have negation. These two are at the same level. So your conjunction and your disjunction and your or, they are in at the same level, followed by implication, and then the lowest of all of them is biconditional statement. All right. Now there's something I need to mention, even though it's not here, is BODMAS. All right. I'm sure you guys remember this from high school. BODMAS. All right. Now I'm mentioning BODMAS, not that we'll be doing addition and subtraction of sentences. Is to notice that this bracket is always very important. All right. So if I give you a compound statement, your biggest priority should be you treating the brackets. All right. So although we're not doing multiplication, addition, and subtraction, but that bracket, that B, that bracket is very important. So if you have maybe P implies Q, and then I ask you for, let's say, or, let's say R. All right, so very important. You, without even thinking, you know you're gonna start here. You start with bracket. So whenever I give you a compound propositional statement, think of the bracket first. All right, think of BODMAS, bracket first, and then when you look at that bracket, then you can start looking at this priority here. All right. If everyone is happy with BODMAS, let's move on. Let's see if we're going to get a nice example where they use BODMAS. Yes, we actually have a nice one. This one here. Let me just scroll a little bit more. All right, so this says suppose we know that Mary is clever is true. All right, Mary is clever, and then I tell you that that statement is true. All right, Mary is lazy, I tell you that it is false. That statement there is false. You know that the statement is false. All right, Mary likes mathematics. Again, I tell you that that statement is true. Now I said determine the truth value of the compound proposition. Mary is not clever, or if she likes mathematics, then she is clever and not lazy. All right, guys, don't get confused with this whole gigantic statement here. Just solve it logically. How do we solve it logically? You have to do the steps. This is the first step. So if I see this in my test, I know you were in my class, actually. So break it into pieces. So the first one, Mary is clever. Just let Mary is clever to be the statement P. So let P stand for the statement Mary is clever. Mary is lazy. You can say that is Q. Mary likes mathematics. You can say R. Now, this statement, I want to write this statement using logical connective. Remember, the use of logical connective is to connect those propositions or those sentences. All right. So Mary is not clever. All right. So if P stands for Mary is clever, therefore Mary is not clever is going to be not P. All right. Then they say or. We know exactly what or is this junction. Is that one? V. All right. Now read carefully. They say if she likes mathematics, then. So the catch here is the if and then. So you read these two at the same time. If, then. It means you have something implying something. All right. If she likes mathematics, so you know already that she likes mathematics. That was the statement R. So it means you have arrow implies something, right? So arrow implies, you see now I'm introducing bracket, right? So I have a little bracket. So arrow implies, then they say she is clever. All right, Mary is clever is P. Then they say and. You see that? That's and there they say not lazy. Mary is lazy is Q, therefore not lazy is just not Q. You see, so it's arrow implies P and not Q. All right, because the if is there and then the then follows with this whole statement here. All right, that whole statement there. She is clever and not lazy. Once you succeed in getting this, there's no way you're gonna get the final answer wrong. Why am I saying so? Because I told you that this statement, Mary is clever, is true. It means wherever you see P, you replace it with a true because you know the truth value. You see, I put a T there to say that P is true. Okay, let's see. They say Mary is lazy is false. Remember, Mary is lazy is actually Q. The variable there is Q. So wherever you see Q, you put a F. F there is just for false. You see, they have a false. And then for arrow, Mary likes mathematics. They say Mary likes mathematics is true. Look here, it's true. It means that wherever I see arrow, I'll just replace it with a true. There you have a true. And then obviously we've already seen P. P is also is true. So I move from this statement to the new statement. Let me just change the color so that we see. So we move from there to here. All right. Now we actually have this. Now, when we need to think of two things. So the order in logical connectives and BODMAS. All right, very, very important. The order in logical connective and BODMAS. But what did I say? I told you guys that BODMAS takes priority everywhere you're talking of mathematics, whether it's logic or it's applied mathematics or it's in calculus. BODMAS brackets takes priority, right? So we're going to focus on brackets. So you need to deal with this bracket. All right. However, if you notice quickly, this statement here is not affected by the bracket. So not true. I'll just say it's false because it doesn't actually affect our bracket. Now I focus on the bracket. Now, if you have more than one bracket, start with the one that is very inside. All right. So I have a bracket. I have another bracket. You start with the innermost bracket, so the one that is inside, before you move to the outer one. So it means my focus is on this bracket here, this one here, the one that's inside there. Right. Just change color. So everyone can see I'm applying BODMAS. So I'm starting with that guy there. So looking at that bracket there, notice it. I need to deal with. I'm going one step at a time. So I need to deal with this not false. Not false is actually true. You see, it becomes true and true. All right. So this not false becomes true. Then my next step is to, again, I'm still looking at that same bracket. What is true and true? Obviously, if two statements are true and you're using and, the outcome is just true. You see, that's how I got this other true here. All right. So I get the true there. Let me just get my annotation again. All right, so that's how we have this true here. All right. Now we're done with the inner bracket. We look at this bracket now. So this bracket, the outside. What is true implies true? Again, you know true implies true is true. So you're going to end up with false or true. All right, let me just go down quickly. There you go. So you see, true implies true. You see it's true. And they just have false or true. Remember what I mentioned about or, all right? Or means you just need one statement to be true for the entire thing to be true. So in this case, definitely it's going to be true, all right? Because at least one of them is true. You see, it means that this whole complex English there, which most of you again would tell me, it doesn't make sense to me, is actually true, all right? This is how logic works. This is the power of logic, all right? And guys, that's the end of our lecture for today. Is there any question?